Hey guys, I got a video for you on stoichiometry, our new unit. It's called stoichiometry, or I call it stoic. So here's just a definition for you of what stoichiometry is. It's the relationship between quantities of reactants and products in a chemical reaction. So when we balance an equation, we often call those coefficients the stoichiometry of the reaction because it's the relationship between reactants and products. And then we're also going to use stoichiometry as like a process. We're going to do stoichiometry to figure out how many reactants we need or how much product we are going to produce in a reaction. All right, here are the steps for doing the superstar stoichiometry method. First step, always make sure your equation's balanced. If it's not, you need to balance it. The next thing is they're going to give you some numbers for the reactants, for the products, whatever they give you, make sure it's in moles. Okay, we're going to use the BCA table. Before, change, and after is what BCA stands for, but you're only allowed to plug moles into your BCA table. So you need to use some mole island to go from grams to moles or liters to moles or whatever they give you. Once you're in moles, we're going to plug in the before boxes. Then we can fill in the change boxes. So remember, reactants are getting used up. So we do like minus 1x, minus 2x, minus 3x, depending on the stoichiometry, the balanced equation. And then products are made or produced. So we do plus 1x, plus 2x, plus 3x, or whatever the stoichiometry is. Next, we need to find the superstar, and we do that by figuring out x. So we take the moles in our before and divide it by the coefficient for each reactant. And whatever value is smallest, that is our x, that's our superstar, our limiting reactant. Okay, then we plug in that superstar's value for x, and it's all about the superstar. And we're going to solve for our after. And remember, the B box, the before plus the change equals the after. Sometimes it's minus C, right? Because sometimes we have the negatives. But plus a negative, you're going to get the same thing. Okay, and then if they want the answer in moles, you're good right there. But if they want something different, then you're going to have to convert from moles to grams or whatever they're asking for. All right, here's our first problem. If you start with 2 moles of SiO2, how many moles of SiF4 would you produce? So step 1, we got to balance this equation. Don't worry, guys, I got this one. 1, 4, 1, 2. Okay, step 2 is we have to look at what's given. And in this case, 2 moles of SiO2 is what's given. And we need to convert it to moles. Well, that's so nice, Miss Buller. This one already is in moles. So I'm going to say before we have 2 moles. Okay, and then how many moles of SiF4? So we are looking for how much is produced of this product. When they don't tell you one of the reactants, we are assuming it's in excess. A lot of times they'll say with excess HF, but if they don't mention it, assume we have excess, it's not running out, we're not worried about it. And then our products are going to always start with 0. We don't have any of these guys before we actually mix the chemicals. Okay, now we're going to do our change. So this guy gets minus 1x because of the 1, minus 4x because of the 4, and then remember our products we're making plus 1x because of the 1, plus 2x because of the 2. So now we need to find our x, and the way we do this is we're going to take our before divided by the coefficient. So for SiO2, we're going to get 2 moles divided by 1, which is just 2. And for HF, we're going to get excess moles divided by 4. Well, a lot divided by 4 is still a lot, so we still have excess. But what we're going to end up doing to find our superstar is we're going to compare those two answers. And the smaller one, oops, that's not what I want. The smaller is going to be our X, which means this chemical is our limiting or our superstar. So in this case, 2 is our x, so we're going to plug in negative 1 times 2, negative 4 times 2, 1 times 2, plus 2 times 2. Okay, so that's minus 2, minus 8 when you multiply, plus 2, plus 4 when you multiply. So now the last step is we're going to take our before, and we're going to subtract from it the change. 2 minus 2 is 0 moles of SiO2 remaining. Excess minus 8 is going to give us excess moles of HF remaining. And then 0 plus 2 gives us 2 moles of SiF4 produced. and 0 plus 4 gives us 4 moles of H2O produced. This question asks for how many moles of SiF4 would you produce, so there's my answer right there. 2 moles of SiF4 will be produced. All right, team, let's try another one. If you start with 1 mole of Fe2O3, how many moles of Fe would you produce? Before I worry about any of those given values, I need to balance this equation. So I notice that I have 2 aluminums on the product side and only 1 on my reactant side, so I'm going to put a 2. Oops, sorry about that. Put a 2. 2 Fe's on the left. I need 2 on the right. And then everything else should be 1, so we're good there. So now let's look at what's given. If I start with 1 mole of Fe2O3, so that goes in my before box, I have 1 mole of Fe2O3. How many moles of Fe would I produce? So produce is my after box, so this is what we are ultimately looking for. Notice they did not mention how much aluminum I have, so I'm going to assume that they want me to say it's excess, meaning I have more than I need. I'm not going to run out. I'm not worried about it. And then Al2O3 is on the right side of the arrow. That's a product, which means I'm starting with nothing. Obviously, if I look in my pantry and I see spaghetti and I see, or some pasta and I see some sauce, that's great. Those are my ingredients, but I don't have any pasta yet or any spaghetti with meatballs yet until I actually do the cooking. So I also start with no Fe to begin. None of my products should have a starting amount. Now we're going to figure out the change. Well, I am going to use up some of my aluminum. How much? I'm going to use up 2 times this value X. Where's the 2 from? From that balanced equation. I'm going to use up 1 times X of the Fe2O3. And now my product side I'm going to make, so plus 1 times X because of the 1, and plus 2 times X. Well, now I want to actually plug in X, so we need to find what that is. So down here off to the side, I'm just going to find X. So for aluminum, I'm going to take the excess divided by the coefficient. So I have, I have excess mole divided by 2. Well, excess just means I have a lot, so a lot divided by 2 is still a lot. And for my Fe2O3, I'm going to take my moles, 1 mole, and divide it by the coefficient 1. Well, 1 divided by 1 is 1. That is clearly, out of comparing these two, that is clearly smaller. So that is going to be my X, which means if X is 1, this Fe2O3 is my superstar. He is my limiting reactant. It means he is going to run out. So now let's plug that guy in. 1 times that 2, 1 times 1, plus 1 times 1, plus 2 times 1. That'll be a minus 2, a minus 1, plus 1, plus 2. Now I'm going to find my after box, and to do that, I'm taking my before plus my change. So I'm taking my excess minus 2, my 1 minus 1, 0 plus 1, and 0 plus 2. So excess minus 2 will still give me excess moles of Al remaining. 1 minus 1 gives me 0 moles Fe2O3 remaining, which is a sign of my superstar, right? It's all about the superstar. It should be running out. I should have 0 left over. Now my product, 0 plus 1 gives me 1 mole of Al2O3, and I'm going to use the word produced because we're making that, and 0 plus 2 gives me 2 mole of Fe produced. The question is ultimately asking for Fe, so I'm going to circle that guy as my answer. 2 moles of Fe are produced. All right, do me a favor. In your packet, let's skip to number 4. I'm going to show you one where you have to kind of think backwards. Still, first step, I'm going to balance this equation. So this case, it's actually really easy. You can pause the video and double check for me, but I got all 1s across. But here's where we're a little backwards. If you manage to produce, so I am making 3 moles of CaCO3. Well, if we look, CaCO3 is a product. So what they're saying is I am making 3 moles of CaCO3. how many moles of CO2 did I start with? So now I want to know how much of this did I start with. Okay, so let's fill in what we know. If we're looking for some number in this box and they don't mention CaOH2, that means he is my excess. So I have excess of this guy. CaO3 was produced and H2O was produced, but they are products, so we must be starting with 0 moles as our beginning amount. Okay, we can still go through the same way. I'm going to use up minus 1 times x. I'm going to use up minus 1 times x. Again, I have a certain amount here. I just don't know how much right now. Okay, we had to make 1 times x, and we had to make 1 times x. Excuse me. Plus 1x. Okay, I don't really need to know much about the H2O, so I'm just going to put an x through that. But now we need to find x, and typically, remember, we would take excess divided by 1 and compare it to this number divided by 1 to figure out which one is smaller. In this case, we have to do something different to find x because I don't know what this number is right here. So here's what we're actually going to do. We are going to use this column to help us find our x because remember, B plus C equals A. So for CaCO3, that column, 0 plus 1x equals 3, right? 0 plus 1x equals my A. So if I know this 0 doesn't mean anything, so if I have 1x equal to 3, divide both sides by 1, that means x is going to be equal to 3. That's the only way we could have gotten 3 moles here. So if my x is equal to 3, this guy's kind of my one we're focusing on because they gave us information. And we use that to find our x. So now let's actually plug in. We have minus 1 times 3, minus 1 times 3, plus 1 times 3, plus 1 times 3. Excess minus 3 is going to be excess. Question mark minus 3 has to equal something. Well, what do we know? If this one's excess, that means this one must have been my superstar, right? This one must have been the one that ran out. And what do we know about the superstar? It always ends at 0, right? The superstar always runs out. So now, if I say my question mark minus 1x equals 0, and we know question mark minus 1 times x is 3 equals 0. What does question mark have to be? Question mark has to be 3. What that means is this must have been 3 moles to begin, right? 3 minus 3 would give us 0 for our superstar. So I can answer this question backwards by using the given information of what was produced. I know that if I made 3 moles of CaCO3, I must have started with 3 moles of CO2. Why? Well, when I worked backwards through the stoichiometry, that's what it told me for this box right here. There's my final answer. All right, last one for this video. Skip ahead in your notes packet to number 6. You can go back and do the other ones for your homework. But this problem says if you start with 319.2 grams of Fe2O3, how many moles of Fe will be produced? So I'm going to balance this equation pretty quick because, again, the focus of this video is working on the stoich. I got 1, 3, 2, 3. If you need help with balancing, that's a great thing to come in and get some help on right after spring break or whenever we're watching this video. After balancing the equation, the next step is we have to plug in our before box, but remember, we're only allowed to plug in moles to our BCA table, and they gave me grams of Fe2O3. So the BCA table only works if we have moles. So we need, I'm going to take what's given, switch colors maybe, here we go. So I have 319.2 grams of Fe2O3, and I'm going to times that by 1 mole over the molar mass, which is grams. That way, when I multiply and divide by what's on bottom, my grams will cancel, and I'll be left with moles of Fe2O3. Well, how do I find molar mass? Well, let's do a little refresher. To find the molar mass of Fe2O3, we need to take 2 times the mass on the periodic table for iron, Fe, which is 55.85, plus 3 times the mass of oxygen, which is 16. So I'm using the 2 times iron, the 3 times oxygen. Once we multiply 2 times 55.85, 3 times 16, add those pieces together, I got 159.8 grams per mole, which is the molar mass. So what that means is 1 mole is equal to 159.8 grams. So in my calculator, I take 319.2 times 1 and then divide that answer by 159.8, and I get 2 moles of Fe2O3. So I'm going to plug in my before. I have 2 moles of Fe2O3. Did they mention CO in the problem? No, so I'm going to assume that I have excess moles. Because they didn't mention the other reactant, I'm going to assume I have more than enough. I'm not worried. Before we do any mixing, any reacting, I'm not going to have any of my products. Oops. Try that again. So, oh goodness. 0 moles, 0 moles. Now we can do our change boxes. So we're going to do minus some proportion of X minus some proportion of X, because those are getting used up. Plus some proportion of X plus some proportion of X. What do we multiply by? Well, we use the recipe, which is the balanced equation. We call that the stoichiometry. So minus 1, because of there, times X, minus 3X, 2X, and 3X. All of that coming from the balanced equation. So now let's find my X. In order to do that, I am going to take my before and divide it by my coefficient. So I'm going to take, for Fe2O3, I'm going to take 2 moles divided by 1 and get 2. For CO, I'm going to take excess moles divided by 3 and get excess. What's smaller? My number 2 right here. So that becomes my X, which means the chemical that gave me my X value, Fe2O3, that is my superstar. So if X is equal to 2, that's what we're going to plug in to each of these. Minus, minus, plus, plus, 1, 3, 2, 3. And now let's plug in that X value. X is equal to 2, and it's all about the superstar. So notice I use the same X value for all of them. Okay, let's do a little math. So that's going to actually be minus 2, minus 6. I'm just multiplying, plus 4, plus 6. And finally, we are going to take B plus C to get our A box. So 2 minus 2 is 0 mole of Fe2O3 remaining, which makes sense. My superstar should always run out. Excess minus 6 is still going to be excess, right? We had extra ingredients. We use up 6 in the recipe. I still have extra. Now the products. I started with nothing. I made 4, so I have 4 moles of Fe produced. 0 plus 6 is 6 moles CO2 produced. This question is asking how many moles of Fe will be produced. There's my answer right here. It is possible that they could have said how many grams of Fe would be produced, and then in that case, I would take my answer of moles and hop back on to a little flashback here. Hopefully you brought your mole island home. If not, here's one for you to look at. But right now I have mass of Fe2O3, and in order to plug into my BCA table, I need moles. So we're going to take what's given, and we're going to cross this bridge. So we'll take what's given and multiply by 1 mole over mm, and remember, mm is the molar mass. So let's flip the island, right, and go from moles back to grams, but now I would use the molar mass of Fe. Or if they ask for anything else, we would use transitions to the other islands. All right, hopefully that was a good overview. You should have now enough information to finish the introduction to stoichiometry notes and practice, and then you should be able to start the limiting reactant POGIL. It's got a little bit of new information, but I think you can figure it out, at least to give us a starting place for after spring break.